moving on to the next one. The second one, we have to find a valoration for P2 negation of P1, P2 implicating P3. We must find a set of inputs. So again, it's a truth table. So P1, P2, P3, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. You'll get used to this if you don't already do it as quickly, but you'll get the hang of it. So this is, so for the first one, all of them shall be, okay, so before we do anything, let's check that we have it written correctly. Indeed we do, okay. So we need to find a set of inputs, okay, so any one row of these that gives us an output for every single one of these formulas, which equals a valoration of 1. That's what makes it satisfactory. Okay, so let's begin with 0, 0, and then 0 is 0. And so, in this case, so this negation will be, actually let me write them all. Find a valoration, so we need only find one, so let's actually just do one at a time. So this one will be 1, so that's fine. This one will be 0, so immediately this one does not fit. This is not satisfactory. The next one, so 0, 0, 0 and 1. We can see that this is also not satisfactory because the P2 is 0. So let's do a smart decision and skip all of the portions. Let's skip all of the rows where P2 is equal to 0. So let's cut these ones out and also those ones. And now we only have to test 4 of them. Okay, we're strategizing. So in this case, so the first one, we get 1 for P2, and then we get 0 for P1, 1 for P2, and 0 for P3. Alright, so this returns 1. That's looking good, but this one returns 0, so this is not satisfactory. Next up, we try this one, so 0, forgive me, okay, so P1 is 0, and these are 1. So this one will be 1, this one will be 1, and this one will be 1, so this one is satisfactory. So we found one. So the set P2, how should I put this? Maybe in matrix form. So a satisfactory set would is P1, P2, P3 equaling, so as a vector, right? So, or would be, it's the same thing, but it's just it looks better this way. So is S where S equals P1 equals P1 equals 0, P2 equals 1, and P3 equals 1. There is so many ways that you can write this, but yeah. Okay, we still have some space down here, so let's just scratch that second one as done. And let's snatch these last three down here and keep at it. So this is a slight waste of space, but you know what, it's fine. It's virtual paper. No trees are being burnt down for this. Except electricity requires, well, some percentage of it. Anyways, let's not digress. So 3, and we got this one. So this time we got P2, P2, P3, and P4 conjunction P3. Alright, and evaluation, so we got 1, 2, 3, 4 variables, so P2, P3 and P4. And then if we go ahead and try them out, so immediately we see P2 isolate. We can isolate the cases where P2 is 0, which won't serve the intended purpose. And then we can strategize again and look at P4 and P3, and we see that the conjunction, well, for it to output 1, both of them have to be 1. So we're looking at cases where both of P3 and P4 are 1. So it leaves us with this case, which is the only case that could support a valid answer, but we still have to check it with this condition. So let's see, 1, 1, 1, 1, 1. We know that this becomes 1, this is 1, and this is 1. So the answer has a valid set, or a satisfactory. Has the satisfactory. The satisfactory set S And in truth, the exercise asks us to specify up to P10 from from P1 to P10, but since none of them are present in the set of formulas, we can simply state that they can be whatever. Like they can be so P5 can be 1 or 0, it doesn't matter. So let's just do an etc. for those. Okay. Good, so we've done the third one, so let's do the fourth. Okay, again we have how many variables? 1, 2, 3. So truth table, P1, P2, P3. Sorry. Now let's look at some obvious ones. Let's look at these ones first. So immediately so the conjunction requires for it to be a valuation of 1, both P1 and P3 must be 1. So any P1 and P3 which is not at the same time 1 is immediately discarded. So it gives us these two. Whoops. Gives us these two. And then we can do what else? What else can we do? P1 and at the same time P2. If we look at this one, this part, this expression, or this formula, same thing. We must have a P1 which is 1 and a P2 which is 0. So this one doesn't fit. And finally, so we here in order to have 1, in order for the valuation to be 1, we must say that the implication of P3 upon P2 the implication of P3 upon P2 has to be 1, but it is 0, so the valuation is 0. So unfortunately, following this strategy has given fortunately has given us a quick answer in saying that has no set satisfactory set of propositional variables.